and today we are going to talk about function machines. But before we talk about what function machines are, let's talk about juicers. Here is a juicer and I want to make apple juice. So all I have to do is put an apple in the juicer and it will make apple juice for me. Anytime I put an apple in the juicer will make apple juice. My input is the apple and my output is the apple juice. If I were to put an orange in the juicer, I couldn't expect to get apple juice from the juicer. I would get orange juice. For each type of fruit I put in the juicer, I get the same type of juice from the same fruit that I put in. This juicer is kind of like a function machine. But instead of apples and oranges, a function machine accepts numbers. We just have to remember that a function machine, just like the juicer, is predictable and does the same thing over and over again. Let me show you how a function machine works. A function machine accepts a number or a set of numbers which we call as inputs, does something to that number and changes it into a new number which we will call as the output. An input goes in, something happens to it inside the machine, and output comes out. Another input goes in, another output comes out. What's going on inside the machine? For example, if I input the number 1 in the function machine, it gives me an output of 3. If I input the number 2, it gives me an output of 6. If I input the number 3, it gives me an output of 9. It would really help us understand each function machine better if we listed all the inputs and outputs in what we call a function table. A function table normally has 2 columns, one on the left for the input values and one on the right for the corresponding output values. In our example, here is what our function table would look like. Now you realize that our function machine just multiplies the input by 3 and giving us the output. So, if the input the number 5,000, what would be our output? Since function machines are predictable and does the same thing over and over again, we know that whatever number we input, the function machine would just multiply that input by 3 and gives us an output. So, 5,000 multiplied by 3 is 15,000. And just like our juicer, which can only give us the juice of whatever fruit we input, this function machine can only multiply any input by 3. It cannot do anything else. We also can imagine this function machine asking, "What's my rule?" If we examine the inputs and outputs, we should be able to figure out what this function machine does or find the mystery function rule. In this case, this function machine multiplies any input by 3. That is this function machine's rule. Let's try another function machine. Can you guess what this function machine can do? If I input 1, 4 comes out. If I input 2, 9 comes out. If I input 3, 14 comes out. If I input 4, what number will come out? Let's write it on a function table, shall we? Because there is a difference of 5 between each output number, I know that there is a times 5 in the function machine. If I put 1 in a function machine, 1 times 5 equals 5, but the output is 4, so all I need to do is put the subtract 1 in the function machine. Now let's check the other numbers. 2 times 5 minus 1 equals 9. 3 times 5 minus 1 equals 14. 4 times 5 minus 1 equals 19. It's correct! Suppose your math teacher gives you this problem to solve for extra credit. 4, 9, 14, 19, blank, blank. It is very easy to find the 6th number in the sequence because all you need to do is add 5 to the previous number. But what if your teacher wants you to find the 2000th number in the sequence? A problem is not hard if you had 1 or 2 hours to solve for the 2000 number. But when the teacher expects you to give the answer in 5 minutes to get the extra credit, it could be frustrating. Here is where function machines can be very helpful. Using the function machine that we have, we can input 6 and the machine would multiply 6 by 530 and subtract 1 equals 29. We can check that answer is correct if we add 5 twice to 19. For the 2000th number, we just input 2000 and the function machine would do its job. 2000 times 5 minus 1 equals 9,999. And just like that, we have our 2000th number in the series. So this function machine multiplies whatever input by 5 and subtracts 1. We call this function machine's rule, or function rule for short. Let's try a different function machine. This function machine gave me a lot of trouble because after I put 1 in, it looked like the machine didn't do anything because the 1 came out. When I put in 2, 4 came out. When I tried 3, 9 came out. Then I noticed that there was something special about all the output numbers. They were all perfect squares. So I was pretty sure that this function machine was squaring the numbers. And I was right. Of course, we can't be carrying around function machines in our pocket as we go to school, but we can draw our own function machine that would work just as well by using the function tables. One day in school, our math teacher wrote these numbers on the board: 7, 11, 15, 19, 23, and told us to find the 5000th number. I drew this function table to help me like a function machine. Because there was a difference of 4 between each output number, I knew that there had to be a times 4 in the function machine. 1 times 4 equals 4, but the output was 7, so all I had to do was add 3 to the function machine. When I checked all the other numbers, the function machine worked perfectly. Now I knew exactly what to do. I needed to send the number 5000 through the function machine because the problem asked for the 5000th number. 5000 times 4 plus 3 equals 20,003. That was incredible! Function machines can quickly find answers to problems that would take hours. Now, you'll often hear these input and output sets referred to by special math names. The input set, or X, is usually called the domain, and the output set, or Y, is usually called the range, and the function rule can be written as where X can be any input or value that you put into the machine. Now, let's try these problems with what we have learned so far. In the sequence 3, 9, 15, 21, you will eventually reach the number 1047. What term of the sequence is the number 1047? I was doing great until this problem. It was easy to make the function machine, but in this problem, you are given the output and you need to find the input. How can I do that? Based on what we already learned, this is the function rule for this function machine. F of x equals 6x minus 3. If you ever have to go backwards through a function machine, all you do is use the opposite operation. Watch what I do when I go in the reverse direction. Do the opposite operation. Subtraction turns into addition and multiplication turns into division. 1047 plus 3 divided by 6 equals 175. 1047 is the 175th term of the sequence. F of x equals 6x minus 3. To summarize, if we know the machine's function rule and the input, we can predict the output. If we know the rules and the output, we can determine the input. You may not realize this, but functions are used in real life more than you know. For example, the amount of money a person earns, his salary, is a function of his hourly pay rate and the number of hours worked. A car's efficiency in terms of kilometers per liter of gasoline is a function. If a car typically gets 20 kilometers per liter, and if you input 10 liters of gasoline, then the car will be able to travel roughly 200 kilometers. A vending machine, the user puts in money, punches a specific button, and a specific item drops into the output slot. So, the next time you see functions, don't freak out. Just like this juicer, you are very helpful in the real world.